Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your chemistry teacher for this session. So just a little bit about OneClass if you're tuning in for the first time. At OneClass, what we're doing is we're providing some videos and live streams and basically resources for frequently asked questions in subjects such as mathematics and in chemistry. Both are offered in basically the high school level and also in the university and college level. So we've been curating these questions for some time now, and although teachers here at OneClass, including myself, what we're doing is we're verifying these solutions so that you have the best solutions moving forward to maybe any assignments or tests or any upcoming courses that you might face. So what we're doing here at OneClass is we're providing you with the best solutions, and we're going to teach you the concepts through verifying the solutions for you so that you have better tools moving forward in your classes. So my name is Joey. I'm currently an Ontario secondary school teacher in Ontario, and what I'm doing here at OneClass is I'm specializing in subjects such as in math and chemistry. So if you're tuning in for the first time, thank you so much for watching. What we have here is a set of about 10 questions for us to kind of go through, and these questions are going to basically be in the high school level, so anywhere from basically grade 10 all the way up to grade 12, and the next stream after we're going to do some university level questions. So without further ado, let's get started on these types of problems here. Okay, so we have three kind of questions in total here. But I'm just going to look at the first one here, just because they only verified the first one. So they didn't look at these two as well. So I'm only just going to look at the first one here. And this is question 1 for the day, even though it says question 9. Make sure my pen works here. There we go. So it says, it's asking us, what is the strongest type of intermolecular force present in NH2CH3? So we have NH2CH3, and we want the strongest intermolecular force, right? We want the strongest intermolecular force. So with these problems, what I like to do is I like to draw the kind of structural diagram of the chemical compound here. So what we have here is, so we have a carbon here, and it's bonded to, we're taking the least electronegative atom here, which is carbon. So carbon's going to be in the middle here. It's going to be bonded to 3 hydrogens, right? So I have 1, 2, and 3. And then it's going to be bonded to this nitrogen here, which is also bonded to 2 hydrogens here. So I have an N here, and then it's going to be bonded to, you can write this as H, and this is H here. And this here is our chemical compound for NH2CH3. It's asking us which intermolecular force is present. So let's look at the first one here. It's ion dipole. Is ion dipole, does that exist here? And in this case, we do not have an ion dipole, right? We don't have an ion here. It's not being dissociated into water or anything, so we don't actually get our ions here. And as you can see here, we have a covalent compound. So it's not very, very likely to dissociate into some type of solution such as water. So we don't have ion dipole, so that's not the correct answer here. And we're looking for, again, the strongest intermolecular force, right? So I'm going to list out basically all the intermolecular forces first, and then we will rank them. So we don't have ion dipole, so number 1 is wrong. I'm assuming number 2 is London dispersion. I think they just misspelled it here, but we do have London dispersion, right? So we have right here, London dispersion. And we do have this because it's an aliphatic chain. Right? We have carbon, bonded hydrogen, bonded nitrogen, bonded hydrogen. Basically, it's just these weak electrostatic forces that exist in a compound. And again, with London dispersion, the bigger the compound, the more London dispersion forces that they will have here, or the stronger the forces might be. Next one, we have dipole dipole. So we have London dispersion, and we also have dipole dipole. So how we have that here is because I know that my carbon here and my nitrogen here is going to draw out electron density, right? So again, I know that this carbon here is partial positive, and this nitrogen is partial negative, because this one, again, I have a lone pair. You can think of this on nitrogen here, and it's pulling away electron density. So this is here is partial negative, and this carbon here is partial positive. So the dipole is shifting here. You can think of the dipole here as it's shifting towards the left-hand side here, because it's pulling electron density away from this carbon here. So in this case, we do have dipole-dipole, and this is stronger than the London dispersion, right? So dipole-dipole is currently our strongest one. And then finally, do we have hydrogen bonding? Hydrogen bonding? And the answer is yes, we do have hydrogen bonding. We have, remember, hydrogen bonding only exists with 3 elements. It's hydrogen bonded to either. So it's obviously, I need a hydrogen and hydrogen bonding. Hydrogen is bonded to N, O, or F. And as you can see here, we have these 2 bonds, right? This bond here. This is again partial negative. This is partial positive. This is partial positive. And as you can see, these 2 bonds here, these two guys here, are hydrogen bonding. So these guys here, let me just highlight them in blue instead of box them. So these guys here, yeah, I won't draw the partial. So these guys here bonded to the nitrogen here are examples of hydrogen bonding, because again and they're very, very strong. They are actually the strongest intermolecular force that exists here, besides the ionic forces. So in this case here, we do have hydrogen bonding, because again we have N bonded to H here, and again it's drawing away it's pulling electron density away as well, right? So the hydrogen here is partial positive, it's pulling away electron density. So in this case here, we do have hydrogen bonding, and it actually is the strongest type of intermolecular force within the 3. And if I were to rank them, hydrogen bonding is the strongest one, and then it's dipole-dipole, and then it's London dispersion. So London dispersion is the weakest one. Dipole-dipole is the second weakest, and hydrogen bonding is obviously the strongest intermolecular force. So in this case, the answer here is hydrogen bonding. And let's look at the solution here. And answer 9 here, it says hydrogen bonding, which is correct. So it says, since hydrogen and nitrogen atoms are present in the compound, it is capable of forming hydrogen bonds with other molecules. London dispersion forces are also present, but the hydrogen bonding is the strongest. So this here solution is correct. If we had another NH2 molecule, NH2CH3 molecule, like if I were to draw another one out, you can see that you can actually have, again, it is also attracted to itself, right? So let's draw this out here. And again, we have this here is partial positive. This one here is partial positive. Let's go here is partial negative. We have bonds that are from this nitrogen to this hydrogen as well, right? These guys are attracted to each other, and then these guys, this nitrogen and this hydrogen will also be attracted together. So this here is also our H bonding as well. So again, so all of these guys here are again, make up the strongest intermolecular force. So this here is correct. Again, this person didn't verify this or this solution here as well. So I'm not gonna say this solution is more so the solution is incomplete, because this person was only asking question 9. So they didn't say do these 2 problems as well. So in this case, I'm gonna say solution is correct, because I'm assuming they're only asking 1 question. Good analysis here. Strongest to weakest, and then I'm going to just expand on their answer here. Intermolecular forces, so it's we have hydrogen bonding first, and then we have dipole-dipole, and finally London dispersion. So the solution here is correct.